In this video, we're going to be discussing graphs of exponential functions. So an exponential function is a function in the form f of x equals b to the x, where b is just a number being raised to a power, and the variable is in the power. Some examples would be like h of x equals 2 to the x minus 5. So you can see that this is just a number, and the variable is up in the power. Or 3 to the x power, or 5 to the 2x power, or another one would be 4 to the x minus 6. The key thing is that in an exponential function, the variable is in the exponent. So exponential function graphs look like this. They have this curve to them, they're a curved graph. And exponential functions have what are called asymptotes. And asymptotes are lines that the graph approaches but never actually touches. Exponential functions have horizontal asymptotes. So in this function, we can see that this graph is getting closer and closer and closer and closer to this line, y equals 0, y equals 0, and it's approaching it, but it's never actually touching the x-axis. So the x-axis is the asymptote. All right. Now, some transformations of exponential function graphs. Okay, we've done transformations before. The number out front, this a, all right, that stretches or compresses the graph, makes it wider or thinner. Up here inside the exponent, this h moves the graph left or right. Okay, if it's minus, it moves it right. If it's plus, it moves it left. This k on the outside is what moves the graph up or down. Okay, so k moves the graph up or down. Plus moves it up, minus moves it down. And also, the equation of the asymptote is always going to be y equals k. So this k value out here tells us the asymptote of this graph. So let's look at an example. So example 1 says, state the parent function, transformations, and asymptote for this function. So I've got f of x equals 2 times 3 to the x plus 4 power minus 5. So the parent function is f of x equals 3 to the x power. And our transformations are that it is stretched by 2. That's what this 2 tells us. This x plus 4 means that it's moved left 4. And my minus 5 on the outside means that it's moved down 5. And remember, the asymptote is given by the k value out here. So our asymptote is going to be at y equals negative 5. All right, another example. Okay, we want to graph this equation and fill in the characteristics of f of x equals 2 to the x minus 4. So first off, here's our graph. Okay, and I just used some points that I got off a graphing calculator, like 0, negative 3, and 2, 0 to graph this. And there's some things we can fill out from it. One thing, we can see the asymptote is down here. The graph is getting closer and closer and closer and closer to negative 4 without ever actually touching it. You can see this minus 4 in our equation. So our asymptote is y equals negative 4. My y-intercept, where it crosses the y-axis, is at 0, negative 3. And the rest of this stuff is just stuff we've done before. The domain, the graph continues forever to the right, and forever to the left, and forever to the right. So the domain is negative infinity to positive infinity. Okay. Now, the range is a little different. This graph is flattening out. So it's getting really, really, really close to negative 4, but without ever actually touching negative 4. And it's never going to be less than negative 4. But then it continues up for forever. So our range, well, this range is actually wrong. This shouldn't be negative infinity. This should be negative 4 to infinity. And notice that this 4 is not getting a bracket, it's keeping a parenthesis, because this never actually touches negative 4, it just gets close to negative 4. For our end behavior, on the left-hand side, as x goes to infinity, f of x is going also to infinity. And on the left-hand side, as x goes to negative infinity, oh, this shouldn't be negative infinity. This should also be negative 4. Because although x is never actually, or f of x is never actually getting to negative 4, that's what it's approaching. It's getting closer and closer to negative 4. So those are the things you need to know about exponential functions.